Example 10.1. The mass of a Earth is 6 into 10 raised to 24 kg. Okay, here you have given that the mass of a Earth is 6 into 10 raised to 24 kg. And same way, if you see that the moon, okay, mass of a moon is 7.4 into 10 raised to 22 kg. Okay, if the distance between the Earth and the moon is 3.84 into 10 raised to 5 kilometer. Okay, so here you can see that distance is also given. How much? Okay, 3.84 into 10 raised to 5 kilometer. Okay, so here you can see that the mass of a Earth, okay, which is given is 6 into 10 raised to 24. Mass of a moon, which is indicated by the small m, 7.4 into 10 raised to 22 kg. Okay, so same way, and distance is also given, but it is in a kilometer. Okay, so first we have to convert it into a meter. Okay, for converting it into a meter, we have to multiply a given kilometer, which is 10 raised to 5. Okay, with 1000. How much? With a 1000. Okay, so we will get 3.84 into 10 raised to 8 meter. Okay, this will be our distance. Okay, and as you can see that capital G is also given. Okay, G is equal to 6.7 into 10 raised to minus 11 Newton meter square kg inverse square. Okay, so here you can see that we have a formula of universal law of gravitation, which is F is equal to capital G into capital M into M upon D square. Okay, so substituting all the value, okay, which we are having, okay, of capital G, capital M, which is the mass of a Earth, and same way small m, which is the mass of a moon, and D, you are knowing that distance. Okay, but mind where that distance D, okay, is in a square. Okay, here distance you can see that it is in a square. Okay, so we have to make a 3.84 into 10 raised to 8 meter whole square. Okay, so it will be in a whole square. Okay, on simplifying it, okay, we will get 2.01 into 10 raised to 20 Newton. Okay, so this will be the force, okay, which are exerted by the Earth on the moon. Okay, so from this we can see that we have derived. Okay, in question also you can see that we have to find a force exerted by the Earth on the moon, and it will be how much? Okay, 2.01 into 10 raised to 20 Newton. It will be 2.01 into 10 raised to 20 Newton. Okay, now the next is the importance of the universal law of gravitation. Okay, what is the importance of a universal law of gravitation? We have studied, okay, universal law of gravitation, but what is the importance of that universal law of gravitation in our life? Okay, and how it is applicable? Okay, all these things we will study in this topic. Okay, the universal law of gravitation successfully explain a several phenomena. Okay, several phenomena will be explained through a universal law of gravitation. Okay, which were believed to be unconnected. Okay, which are very unconnected. But here you can see that the force that bind us to the Earth. Okay, the force which are binding us with the Earth. Okay, for that also it is important. Secondly, okay, the motion of the moon around the Earth. Okay, the motion which are seen of a moon around the sun, Earth. Okay, around the Earth. Okay, that is also second importance. Now the third one. Okay, the motion of a planet around the sun. Okay, motion of a planet. We know it very well. Okay, that also due to this law of gravitation, universal law of gravitation. Okay, same way the fourth is the tides due to the moon and the sun. Okay, the tides which are due to the moons and sun. That is also one of the importance of a universal law of gravitation. Okay, now we will study about a free fall. Okay, now first let us try to understand the meaning of a free fall by performing this activity. Okay, several activity we will study about the free fall. Okay, we have learned that the earth attract object towards it. Okay, we know it very well that earth will attract all the object towards it. Okay, earth is attracting object towards it. Okay, this is due to the gravitational force. Okay, it is because of what? Okay, because of a gravitational force, earth will attract all the object towards it. Okay, whenever an object fall towards the earth under the force alone, we say that the object are in a free fall. Okay, now one of the important, when we are releasing an object, when we are releasing an object from a certain height, from a certain height we are releasing a object. What will be seen? The object will go in a downward direction. So it will come down. So from this we can see that there is a certain force which are exerting on that object, due to which, because of which, the object is coming downward. Why? Because of a certain force, which are exerting on that object, due to which we can see that the object will come down. So because of that force, the object will come down. And the phenomena is said to be free fall. Phenomena is said to be a free fall. Is there any change in the velocity of a falling object? While falling, there is no change in the direction of a motion of an object. There will be no change in the direction of an object of a. So from this we can say that the object will form or object will fall in a unidirection, which will be in a downward. Because of whom? Because of a gravitational force. Because of a gravitational force, object will fall in downward direction. But due to the earth attraction, there will be a change in the magnitude of a velocity. Because of what? Because of a earth attraction, there will be a change in the magnitude of a velocity. Velocity will be changed, magnitude of a velocity will be changed. And we know it very well. If the velocity is changing, then acceleration will be seen. Any change in the velocity involve acceleration. So just now we have discussed that if the change in a velocity will be seen, it will involve acceleration. It is said to be acceleration, because we know it very well. A change in a velocity is said to be a acceleration in certain time. So whenever an object fall towards the earth, when an object is falling towards the earth, an acceleration is involved. And due to which it will involve acceleration. And this acceleration is due to whom? This is acceleration due to earth's gravitational force. And the acceleration which are saying, that is because of whom? It is because of earth's gravitational force. And therefore this acceleration is called the acceleration due to gravitational force of earth. Here you can see that earth's gravitational force. The acceleration due to the earth's gravitational force is said to be what? It is said to be a acceleration due to gravitation. Therefore this acceleration is called acceleration due to gravitational force of earth. Once again I am repeating. We know it very well that acceleration. But here in this case you can see that acceleration is seen. Acceleration is seen, but it is because of whom? Acceleration which we are saying is because of a earth's gravitational force. Okay, because of the Earth's gravitational force, acceleration is seen. Okay, and so this acceleration is said to be what? Okay, acceleration due to gravitational force of the Earth, or we say it as acceleration due to gravity. Okay, so it is denoted by small g. Okay, so acceleration due to gravity is what? Okay, acceleration which are seen because of the gravitational force of a Earth. Okay, and due to which, okay, acceleration is seen, and because of gravitational force. Okay, and it is indicated as a small g. Okay, it is indicated as a small g, and the unit of the small g is same as that of a acceleration. Okay, acceleration unit we know it, meter per second square. Okay, so here small g will be also meter per second square only. There is no change of a unit. Okay, it will be same as the acceleration a. Okay, the unit will be same, meter per second square. Okay, once again it is most important that what is small g. Okay, so small g is the acceleration due to gravity, and it is because of whom? Okay, when an acceleration is seen or a change in a velocity is seen, it will involve what? Okay, it will involve acceleration, and this acceleration is seen due to whom? Okay, it is seen because of the Earth's gravitational force, and so it is indicated as an acceleration due to gravitational force of a Earth and acceleration due to gravity, and it is said to be acceleration due to gravity. Okay, and it is denoted as small. Okay, it is denoted as a small g, and the unit of a small g is meter per second square. Okay, the unit of small g is what? Okay, meter per second square. Okay, we know from the second law of motion that force is the product of mass and acceleration. Okay, we know it very well that force is what? Okay, force is the product of mass and acceleration. Okay, this is the product of mass and acceleration. Okay, from the second law of motion we know it very well that a force F is equal to how much? Okay, F is equal to m into a. Okay, where m indicate mass and a indicate acceleration. Okay, let the mass of a stone in activity 10.2 be m. Okay, we are taking a mass of a stone be small m. We already know that there is an acceleration involving in the falling object due to gravitational acceleration. Okay, when an object is falling from a certain height, okay, we will see that gravitational force will be exerted on it. Okay, or acceleration is seen on that falling object. Okay, and that acceleration is because of whom? Okay, it is because of gravitational force. So acceleration is indicated as a small g in place of a. Okay, so here in formula also we can see that F is equal to what? Okay, m into g. In place of a we will use g, which will be acceleration due to gravity. Okay, and therefore magnitude of a gravitational force F will be how much? Equal to the product of a mass and acceleration due to gravitational force. Okay, so here you can see that F is equal to what? Okay, F is equal to m g. Okay, F is equal to what? Okay, F is equal to m g. Okay, you can see it that F is equal to what? Okay, F is equal to mg, and from the equation we can see that we have a equation. Which equation? Okay, we have a equation F is equal to what? Okay, capital G capital M into small m upon what? Okay, d square. Okay, we have a universal law of gravitational equation, which is F is equal to G m into small m upon d square. Okay, now using this equation and another we have F is equal to mg. So substituting f is equal to what? Okay, m g, we will get a new equation which will be mg is equal to what? Okay, capital G capital M into m upon d square. Okay, this equation we will get. Okay, now you can see that small m and here small m, both the m will be cut. Okay, so our equation will be small g is equal to capital G capital M upon d square. Okay, so we will get a new equation. Okay, here you can see that capital M indicate what? Okay, capital M is the mass of a earth. Capital M is the mass of a earth, and capital D, no, small d, okay, which will be the distance between the object and the earth. Okay, so from this we can see that capital M will be mass of a earth and small d will be the distance between the object and earth. Okay, now let an object be on or near the surface of the earth. Okay, let the object be near or on the surface of the earth. Then what will be seen? The distance d. Okay, distance d will be equal to r. Okay, it will be what? Okay, in previous equation we have seen that mg is equal to what? Okay, capital G m into m upon d square. But here you can see that in place of d square, in place of d square, okay, we are substituting r square. What? Equation will be same, but d, okay, will be substituted as a r. Okay, in place of d we will use r, and r will be our radius of the earth. Okay, what will be? R is the radius of the earth. Thus, for an object on or near the surface of the earth, okay, if the object is on the surface of the earth or near the surface of the earth, at that time we will use r in place of d. Okay, so here you can see that mg is equal to capital G capital M into small m upon r square, and mm is cut, so we will get the equation small g is equal to capital G capital M upon r square. Okay, now the earth is not a perfect sphere. Okay, you can see that earth is not a perfect sphere. Okay, so as the radius of the earth increases, okay, as the radius of the earth increases from the pole to the equator, the value of g become greater. Okay, as the value of earth increases, g value will be increases or greater. For the most calculation, we can take a small g to be the more or less constant on or near the earth. But for the object far from the earth, okay, if the object is far from the earth, the acceleration due to gravitational force of the earth is given by equation 10.7. Okay, so for that we will not write. Okay, now how to calculate the small g? Okay, to calculate the value of small g, okay, to calculate the value of small g, okay, we should put the value of capital G, capital M and capital R, universal gravitation constant. Here you can see that G, capital G will be 6.7 into 10 raised to minus 11 Newton meter square kg inverse square. Okay, capital M, which will be 6 into 10 raised to 24 kg, okay, which is the mass of a earth, and radius of the earth, which is 6.4 into 10 raised to 6 meter. Okay, so we have all the value. Okay, on substituting that value, okay, here we are substituting the value of capital G, capital M and R, okay, which is the radius of the earth. Okay, on substituting it and simplifying it, we will get 9.8 meter per second square, okay, which will be the value of small g. Thus, the value of acceleration due to gravity of the earth, small g, is equal to how much? Okay, 9.8 meter per second square. it will be how much? Okay, it will be 9.8 meter per second square. Okay, so we will get a value of small g, which will be 9.8 meter per second square. Okay.